Welcome to September 27th LeetCode Challenge, Unique Email Addresses. Every valid email consists of a local name and a domain name separated by the @ sign. Besides lowercase letters, the email may contain one or more dots or plus strings, right? Dot character and plus characters. For example, in alice@leetcode.com, we have Alice being the local name and LeetCode.com being the domain name. If you add periods between some characters in the local name part of the email address, the mail is sent to where it's forwarded to the same address without dots of the local name. Note that the rule does not apply to domain names. So, for example, alice.z at LeetCode.com and AliceZ at LeetCode.com forward to the same email address. If you add a plus to the local name, everything after the plus sign will be ignored. This allows certain email addresses to be filtered. Note that the rule does not apply to domain names. So for instance, we have m.y+name at email.com will be forwarded to my.@email.com, right? This is also known as plus addressing. You can set that on your inbox. It is possible to use both these rules at the same time, given an array of emails where you send one email to each email at index I, return the number of different addresses that actually receive emails. Alright, so we're given an email at array here, and we're given a list of emails, essentially, which are strings, and we want to know how many of these are unique email addresses that are valid, right? So it all boils down to we have this email address and this email address, which are valid, right? Because they're following the rules. So let me see. This email address is valid because it has a dot right there. However, it's not applied to domain names, which is interesting. Oh, right, it's just asking you to, yeah, so it's telling you where it receives the email, not actually the emails it gets accepted. Alright, and all three of these are actually accepted because they're all the same form, just different local names. Email length is between 1 to 100, email index 1 to 100, email I, because of English lowercase letter, with character plus, dot, and @ Each email index I contains exactly one @ character. All local domain names are non-empty. Local names do not start with a plus sign. Alright, so to solve this problem, we just need to iterate through or loop through the emails and basically scan out. Just basically fix up the emails, specify the problem above, following two conditions. We can use a set to find out the number of unique email address we have cleaned up. And then let's go through that. So the first thing we do is to make a set. Let's call this a set. No, call it email set. Email set. Which is going to be a set. So we want to place the dot with the space, an empty string, because remember up here, property number 1, the dot right here, and just before to the same email address without the dot, the local name. So basically you want to change that. So let's say for email, in emails, we are going to reassign basically the name and domain name. Yeah, sure, let's go with that. I'm actually going to say local name and domain name. Local and domain. This makes more sense. Email dot split and we basically split the at sign, right? And then we want to basically update the local to know that the local replace each dot we have with a empty string. So next we have two conditions down. If the plus addressing in local, because we have basically do a plus addressing in the local part, name part, then we want to update local name to be local dot. So we want to basically take the array, the slice between local from the beginning all the way to the index of where it starts plussing, where the plus addressing begins. And then we want to basically add this to our set, because we're basically taking, I'll just write it first and I'll explain it afterwards. Let's go our set, we add name, local name plus at plus domain, and return the length of our set. So basically we make a set, right? And we loop through, we iterate through the loop where in each email set, we basically split up the email part from the local name and the domain name at the at sign, right? There's only one at character in each email string. We update local by replacing each dot we have in the local name with this with an empty string, so that's nothing. So we basically follow this rule here, with a period. The local name does not add to the address. By the way, we're iterating through each email and email address to basically clean up the all the random emails here and make sure we find the unique ones. And then in the local part, local name, we have plus addressing, right? So we have the plus sign. So if we find one, we're going to update the local name with the local name from the beginning of the slice all the way until we find the plus index. And then that's basically everything after that is ignored. And then once we're done all the local part with plus addressing, the dot part, and also we split the domain name apart, we just reconcatenate that in local plus at plus domain, and we add that to our set, which keeps track of our unique names, and return the length of the email address as specified by returning the difference address actually received the email. And let's run this and see if it works. Looks good. Accepted. Awesome. So time complexity will be big O of m times n, where we iterate through n emails. In the worst case, we have m characters, right? So m, which is the length of the email list, and m is each character inside the worst character inside the longest character inside the email set list string. Yep, and that's pretty much it. Because this replace function is also big O of m times, right? So for n times m right here. Space complexity would also be big O of n times n as well, because we store the worst case of all n strings of m characters that are not unique inside our email set. So yeah, that's pretty much it for this. There you go. However, I'm just going to show you guys a bonus one right here. So I'm just going to erase most of this actually. So if we know, for instance, we want to return the length of something, right? So we actually use regular expressions to be able to solve this. So let's say that we want to basically do the same thing we did before. So we have an email set we're returning, so we need to have a set here. All right, let's make a set. And then we could use a regular expression of using this sub function here. And the regular expression that we want to keep would be the r times that. Not that. What am I doing? So basically, the regular expression, if you guys know regular expression, it'd be slash dot. So some things you want to be able to keep in would be using the expression question mark equals dot star at, or what am I doing? Or plus sign dot star times question mark equals at. Alright, replace that with an empty string for each string, I guess, for SN emails. That's there you go. So this is using regular expressions. So basically we want to know the length of the set for each string inside of email. We want to basically search for the regular expression that has the following requirements, and we replace that with an empty string for each string. That's just something cool and neat if you guys are familiar with regular expressions. It's always difficult to come up with these type of expressions, but once you do, it's kind of an easy one. Alright, have a great day, guys.